For exercise 1, we will be determining which vessel is more accurate when it comes to measuring density, a 10 milliliter graduated pipette or a 100 milliliter graduated cylinder. To do this, we took the density of different amounts of water measured by both vessels and compared. Density is measured by dividing the mass of a liquid by its volume. To find the volume of a liquid, you simply use the meniscus to measure the amount of liquid present. The meniscus is a concave curve at the top of a liquid formed by the molecular attraction of liquid to the container. When measuring a liquid, you will record the measurement according to the reading at the base of the meniscus. To find the mass of a liquid, you must weigh it. However, you can't just measure a liquid outside of a vessel. It would be too messy. As a result, we must first find the mass of an empty beaker. This way, when we find the mass of the liquid in the beaker, we can account for the weight of the beaker and find the mass of just the liquid. Here, we take the mass of a 25 milliliter volumetric flask and use it to find the mass of the samples of water. Resulting from our data, we concluded that the 10 milliliter graduated pipette was more accurate. For exercise 2, we had to find the density of sugar solutions and find the relationship between the density and the concentration of sugar in each sample. We transferred some of the sugar stock solution into a clean, empty beaker. A stock solution is a concentrated solution that can be diluted to a lower concentration for actual use. To dilute a solution is to make an original solution weaker or less concentrated, generally with water. We then used a 10 milliliter pipette to transfer some of the sugar stock into a beaker and diluted the solution by adding water. We filled the 10 milliliter graduated pipette with stock solution and recorded the amount filled as the initial volume. We then released some of the stock solution into a 25 milliliter flask, recording the amount of stock left in the pipette as the final volume. By subtracting the initial volume from the final volume, we were able to find the volume of the stock solution present in the flask. We then filled the rest of the 25 milliliter flask with water to dilute the solution. Using this information, we used the concentration formula to find the concentration of the stock solution in the flask. Using the formula C1V1 equals C2V2, we were able to find the concentration of sugar in each solution, where C1 represents the concentration of stock solution, V1 represents the volume of stock solution, C2 is the new concentration after dilution, and V2 is the new volume. For exercise 3, we used the data that we collected in exercise 2 to determine the unknown solution given to us in the lab.